This question is unique binary search tree. So you are given the integer n, so return the number of the structurally unique BST. So once again, this question is really challenging, and I'm going to just try my best to explain. So when n equal to 1, you can have what? The node for itself, right? So it could be a node 1 for the tree, for the entire tree, right? And then n equal to 2, you can have what? 1 for the root, 2 on the right, right? Or 2 for the root, 1 on the left. So this is n equal to 2. And let me do the n equal to 3. Alright, n equal to 3 is example 1. And I'm just going to explain what happened over here. So what happened over here is what? When 1 equal to root, right? When 1 equal to root, just look at 1. 3 could be on the right, and 2 could be on the left when there is a subtree of 1, right? So this is what? BST. And 1, 2, 3, this is another one. And then 2 for the root is what? 1 on the left, 3 on the right. And 3 for the root is 3, 2, 1 or 3, 1, 2. This is also work. But look at this. I'm going to just zoom in a little bit closer. So look at this. On the root of 1, the left is 0, the right is 2, right? On this tree, right? This is left is 0 and then right is 2. And then when you go on the go down the next level, right? This is 1, this is 0. When you go down the next level, this is 0, this is 1, right? So there are two ways when you're going down, right? 1, 0 or 0, 1. And this is what? This is a little bit tree. So for this one is 1, 1, right? So 1, 1 is you only have one way. And this one is what? 2, 0. So 2, 0, right? This is also 2, 0, right? So when you're going down, this is 1, 0 and 0, 1, right? So the number of a possible generate, right? The subtree, it determines how many left or right subtree you have, right? So once we know the logic, we can probably use in the memoization, just using a DP for 1D array, and we can just keep calculating the current left for the current n, right? Current left for current n, and the current right for the current n, because your n will increasing, right? And then we are starting from 1 all the way to the n, and then once we reach from the bottom up, right, we can actually calculate the current number for the future n you are trying to get. So this is the idea. So let's just start coding for the first solution. So this solution is going to be using an n squared time complexity. So you will be able to know what happened. And let's just start coding. So I'm going to give you what? N plus 1 space for in array DP. This is because I need to store the index 0, right? So I'm going to say the default index 0 is going to be 1. And then when I want to return DPN. Alright. So once again, I traverse the entire from 1 to n, right? So just imagine 1 to n is what? It's pretty much like this kind of subtree, or this one, right? And then we need to calculate the left and right, based on the number of node, right? So I will have to create another for loop. But in this for loop, I'm going to just based on calculate this sub tree node based on the I. So I'm going to say j equal to 1, j less than equal to I, and then j plus plus, right? I would definitely get a number, the number of a node based on the I, right? And my current DPI is going to be what? Plus equal, because you will just keep adding, right? Keep adding your current index DP for the what? For the left and right possible you probably have to say combination, right? Combination of tree, and then this is going to be dp j minus 1 times dp I minus j. Alright, so what this means is what? dp j minus 1 and dp I minus j. So imagine that I equal to n, and then n, so n minus n is going to be 0, and n minus 1 is going to be what? It's going to be like the tree you have on the left. So this is going to determine like what? The left, and this is going to be on the right, right? So how do I explain? So imagine that I and j equal to 1 first. I equal to 1, comma j equal to 1, and then this will be what? dp. This is going to be what? 0 times dp. 1 minus 1 is actually 0, right? Alright, so now you increase your j by 1, so j equal to 2, but I is actually 1, right? You will break out of j equal to 2 for loop. So you increment I by 1, which is I equal to 2, j equal to 1. You're starting from 1 again, right? And this is going to be what? dp. 1 minus 1 is actually 0 times dp. 2 minus 1 is 1, right? And then we already calculated dp1 equal to dp0 times dp0, right? And dp0 we define is 1. 1 times 1 is 1, right? So dp1 is also 1, right? If n equal to 1, there's only one possible tree, right? If n equal to 2, you have what? 2, right? So this is dp2, but don't forget we need to plus equal. Why? Because we'll increment our what? J equal to 2 later, right? So dp0 times dp1. 1 times 1 is 1. Plus, I'm going to change another color. dp 2 minus 1. 1 times 2 minus 2, which is 0. So plus 1 times 1. So 1 plus 1 is actually 2, right? So and so on, right? You are going to keep calculating, right? So again, I'm going to just submit my code and submit yes. All right, I'm going to just set a breakpoint right over here, right? And you will pause it at any second if you want. I'm not going to explain, but just probably look at the debugger, right? And going down. Alright, so this is the solution, and then you'll definitely get more familiar with this kind of question. I'm going to say this is going to be hard. Alright, so this is one of the solution. I'm going to talk about the next solution. So the next solution is going to be using a recursion, and then you only have one for loop, but you are going to use using a recursion to call the left and right subtree. So the idea is pretty similar, right? So I'm going to say dp equal to what? Equal to new int n plus 1, and I'm going to create a helper function public in, and I'm just using the same function, and I'm going to put in my pass in my dp array into the function, and also the what, and also the n. And when I want to return this one, dp and comma n, sorry. So yeah. So this is the helper function. I'm going to just overload the function name, doesn't matter. Right. So it will initially become what? Become 0, right? And then if n is actually less than or equal to 1, right? You're starting from 1, and then you just return 1, right? And then what if your dp is already have number? So dp at what? dp at n. If dp at n is not equal to 0, you will what? Return dp at n. So you will actually decrement your n from n to 1, right? You will decrement n to 1. So I'm going to have another the sum, so which is going to be called total. So I'm traversing from 1 to n, right? So now I traversing the 1 to n, and calculate my what? Calculate my current total for left and right. combination, something like this, right? So it's total plus equal what? The num time, I'm gonna pass in what? Pass in the dp, and passing the what? Passing the I minus 1 times this one, dp. And what do you think for the right? It's gonna be what? The exactly same thing for what? N minus I. And then when I want to return, I need to set the current value, which is n equal to total, and return what? You can say total or dpn. Alright, so now this is the left, right? Just imagine this is a left and this is a right, right? So when n equal to 1, when n equal to 1, I'm going to say dp n equal to 1, so it's still going to be dp0, so we pass in dp0 into here. And then we already know dp0 is what? Should be 1, right? So less than equal to 1 should be 1. And then you assign 1 back to here, right? And this is what? dpn minus I. n minus 1 is what? If n equal to 3, then it's going to be what? 2. So you will just keep recursive call this function. So but you only call once because you will break out the like an infinite loop. When there is a memorization on a recursion, you will know that this is not equal to 0, and then you will definitely break out. So I'm going to just quickly draw the idea. So I'm going to say this is going to be what? 0, and this is 2, right? And then since you cannot go deeper for the 0, so you'll break out, so you're going up, and this one you'll go what? Go to what? 2 minus 1, right? This is going to be you'll get what? N is current now 2, so n was 3, and then you call 0, 2, and then let me just draw a little bit bigger. So n was initially 3, and then you call 1 minus 1 is actually 0, and then 3 minus 1 is actually 2. Right now n is now 2, right? And then 1 minus 1 again is actually 0, and then 2 minus what? 2 minus 1 is actually 1, right? And this is 1. The left is going to be 0, then right 1 minus what? 1 minus 1 is actually 0. So you actually hit like the base case when there's a 0, right? And this is the entire memorization for a recursion. So I'm going to still commit and then submit. Alright, so let's talk about the time and space. So in this one the space is all of n, right? And the time is going to be all of n right here, but also all of n right here. And the worst case for this one is going to be all of n squared, the time, and this is all of n for the space, right? And if you remember the first solution is like this. This is n for the space, all of n squared for the time. So they are the same, but one is using a recursion to find out the solution, and this one is using a 2 for loop to find out the solution. So this is pretty much the idea, and it's a little bit long, and just make sure you know, like, you need to build from bottom up, because we want to know like when n equal to 1, we calculate for n equal to 2, which is dp. So this is dp0, right? And this is dp1, right? And then dp0 is actually 0, dp1 is 1, dp2 is what? Is 2, dp3 is 5. Okay, so this is what I just made a mistake. dp0 for default value, dp1 for n equal to 1. dp2, we calculate dp2 based on dp1. We calculate n equal to 3 based on what? dp2, so we get dp3. So we need to build from the bottom up. We cannot go from top to bottom. This is not work. This is not working, right? So here's my solution. So if you have any question, leave a comment below. Subscribe if you want it, and I'll see you next time. Bye.